Hello everyone, welcome to simulation class. In today's lecture, you will learn or carry out 3D space frame simulations with SOLIDWORKS. You will learn how you can apply a uniform distributed load on a 3D space frame in order to evaluate maximum bending stresses as well as beams. So let's start our study now. So first of all, we will make a sketch on the top plane. Draw a centered rectangle. Then assign the dimensions to this rectangle. Length of this rectangle is 1500 millimeter, while its width is 500 millimeter. Now exit from sketch. Now make a plane that is 350 millimeter offset from the top planes. So select the top plane and go to the reference geometry. Then select a plane. After that, you have to define the offset distance, that is 350 millimeter. Now copy this sketch by Ctrl and C key on the keyboard, then click on the plane one and paste it by Ctrl V. Then hide the planes. After that, you will define the legs of this 3D space frame. Just go to sketch, then select the 3D sketch, select the line, the infinite line shows that this is the vertical and this line is along the y-axis. Similarly, draw another line. So we have drawn these four lines along the y directions or parallel to y directions. Add equal relations between these four lines, and the length of each line is 750 millimeter. Exit from sketch now. So we have completed the sketch of 3D space frame. So our next step is to assign structure profile to this space frame. Now go to the weldments tab, then select the structure member, and from standards ensure that ISO is selected, from type is pipe, and this is the size of pipe. Click on the group, select this line, okay, this is the first group that has 4 members. Click on the new group, so select these 4 lines. This is the second group and click here. This is the third group, click here. Fourth group, select this line, and in the last this lines. So we have created a structure or weldment profiles or structures here. Now it's time to change the structure profile. So go to the drop down list and click here. Go to edit destinations, edit sketch, The cross section of this beam, these beam is square. So delete this one. Sketch a centered rectangle here. Assign the dimensions, that is 80 millimeter. Ensure that center of this rectangle and origin should be coincide. Make coincident. Draw another, you can see here. But this is the solid profile. We will add the thickness. Again, go to the profile. So again, draw a center rectangle. Add equal relations for both sides of rectangle, and the distance between this line and this line is 5 millimeter. Now our last step is to start the simulation study. Just click on the simulation tab and start the new study. Ensure that static study is selected. Name of study is 3D space frame. Okay. So our first step of simulation study is to assign the material. We assume that this whole frame is made of a simple alloy steel. Apply, close. You have applied the alloy steel material to all members of this frame. Now this frame is fixed with these four legs with the ground. So right click on the fixtures, select the fixed geometry, then select the fixed geometry and select these four joints. Okay. Now apply a uniform distributed loads on these top four members as well as the bottom four members. Again, go to the loads, select the force. From selection box, select the beam. Select these four beams. Then select the top plane. For the reference directions, change units to SI and ensure that per unit length is selected. Select this one. You can increase the symbol size in order to see the direction of applied load clearly. So this is the not proper directions. I think this is the proper directions. Reverse the directions and enter the value of 8000 Newton per meter. Again, copy this load, paste here, then edit definition, remove R selections, then select these bottom four beams and remains unchanged all other things. So we have applied a uniform distributed load of 8000 Newton per meter at top four members as well as the bottom four members. Now our last step is to run our simulation study. So simulation has been completed now. We want to check the maximum bending stress. Change units to megapascal. You can see that maximum bending stress is 45.12 megapascal. That is very less than that the yield strength of the material, that is 620 megapascals. And maximum deformations in the y directions, go to edit definitions and select the deformation in y direction. You can see that maximum deformation is occur here at top these two members, that is 6.2 millimeter in the negative y directions. We can also animate these deformations. So I hope you enjoyed today's lecture of simulations on this 3D space frames. If you have any query, you can ask me any questions in comment box. Thank you for watching. Take care. Bye bye.